All right, let us discuss about polynomial functions. We have already discussed about some of polynomial functions. For example, the first one is linear function. You can see the linear function is given by mx plus b, where m is the slope of the line, and it should be different from 0 in order to define a linear function, and is a polynomial of degree 1. And also we discussed about a quadratic function, which is in the form of f of x is equal to ax squared plus bx plus c, where a should be different from 0, and is a polynomial function of degree 2. So the degree is the highest power in the expression. Generally, the general definition of a polynomial function is the expression, the leading term an x to the n plus an sub n minus 1 x to the n minus 1 up to the constant term. So any function represented by an n and a negative integer is called a polynomial function, and the highest degree in the expression is known as the degree of the polynomial, and those a sub n minus 1 and so on and so forth, they are called real numbers and the coefficients of the polynomial. And remember that the polynomial, the domain of any polynomial function, is a set of all real numbers. So these are the general definition of a polynomial function. Example, let's say example, linear function, 3x plus 5. You can see that the degree is 1, and leading term of this one is a term associated with the degree, which is 3x. This is a linear function. For example, if you consider a quadratic function, let's say minus 10x squared plus 5x minus 10. So the degree of this polynomial is 2, and the leading term it is minus 10x squared. And you can keep going. For example, f of x is equal to 100x cubed plus 3x squared minus 90. This is also a polynomial function because it satisfies the definition, right? All the degrees must be non-negative. So the degree of this one is degree 3, and leading term is 100x cubed. So this one is leading term, and this one is known as constant term. That means a term without any variable is known as a constant term. This is a leading term. So a polynomial can be any degree. For example, if you are given this one, for example, minus 500 x to 1000 plus 5x to 50 minus 200 x squared minus 5. Now you can look at this one. The degree of this polynomial is 1000, and the leading term of the polynomial is minus 500 x to 1000, right? So these are the general definition of a polynomial. Now, what does the graph of a polynomial looks like? Now, look at, these are different examples of a polynomial. For example, the first one is a linear function. You can see that it's a straight line, and the degree is 1. And the second one is, you can look at x cubed minus 2x, which is degree 3 polynomial. This one is, you can look at x to the 5th, the degree is equal to 5. That is this one. And this one is a quadratic equation, which is the degree is 2. And if you look at this one, the degree is equal to, which is 4, and leading term is 2x to the 4th. And this one is degree of a polynomial, which is 6. Leading term is x to the 6th. Now our next discussion will be what will be the behavior of the polynomial. That means the end behavior. The end behavior means when x goes to positive infinity and x goes to negative infinity, to the left side and the right side of the polynomial. Then we'll analyze the graph of the polynomial. Now you can look at this a pattern, right? A pattern, for example, the degree 1 polynomial, when x goes to positive infinity, the polynomial, f of x goes to positive infinity. When x goes to negative infinity, now f of x goes down, negative infinity. So you can look at all these graphs, for example, for the even and odd degrees polynomial, the end behavior will be different. So we'll see those behaviors in the next video.